Boys and girls, when we left off in science, we were just starting to learn about water and we didn't get very far. So I want to continue our journey through understanding the science of water by teaching you surface tension. Surface tension. Well, what it is, it's the bonds of hydrogen and oxygen atoms creating this tension on the surface of water. And so we're going to start off by talking about, of all things, bubbles. Bubbles usually only come as individual spheres of soap and water. Sometimes, if you're lucky, you can get a whole bunch of bubbles in one cluster, but it always seems random. Well, luckily, I found a spectacular way to create entire snakes made of bubbles, and I'll teach you how to make them in all the colors of the rainbow. Well, bubbles form because of the surface tension of water. Let me show you a picture of some examples of surface tension. Of course, here's a water strider, and because of the surface tension of the water, it's able to sit and glide on top of the water and not sink into it. Another example of surface tension is this photograph. It shows a paperclip magically sitting on top of the water, not sinking into it, all because of surface tension. So, hydrogen atoms, let me just show you a picture here, a model of water. So this is what's called H2O, two H's and an O, two hydrogen atoms and an oxygen atom, H2O. And what happens is hydrogen atoms in one water molecule are attracted to oxygen atoms in another water molecule. And they like each other so much, they cling together. Now let's go back to bubbles, because we're going to do a bubble experiment. Why are bubbles round? Well, the physicists will tell you that bubbles enclose the maximum volume of air in the minimum amount of bubble solution, so that's why they're always round. So we're going to make what's called a bubble snake maker. And when you blow air through your bubble snake maker, you are creating hundreds of tiny bubbles. As the air wiggles through the fabric, bubbles are continuously being made. Now these bubbles are going to attach to each other, like we were hoping they will. The bubbles attach to each other when they come out of the fabric, thanks to the same hydrogen bond that makes the bubbles possible. So all of our bubbles clinging to each other is an example of surface tension. The hydrogen atoms are clinging to the oxygen atoms of the various water molecules. All right, now, fun part. Let's make something. So what we're gonna do is we're gonna make a bubble snake maker. And so what you need is you need a bottle like this. It could be a Coke bottle, it could be a water bottle. And you need a parent to get a utility knife or any other kind of sharp, thin-bladed knife, and you will cut the bottom off of it. And I've already done that on this one right here. Okay, from here, I'm going to take a piece of washcloth, a piece of towel, a nice thin towel, and I will put it over, and I'll center it, put a couple of rubber bands on it to keep it in place. Okay, not too hard so far. So this is my bubble maker right here, believe it or not. And what we're gonna do is we need some bubble solution. I've already made some, but I'm gonna try to make sure it's gonna really work well. So this is just water and dish soap. So I'm gonna put some more dish soap in it. I want this to be very, very bubbly. And we'll get it mixed up real nice. And the best part is to come. I'm gonna make some bubbles. Gotta make some bubbles. So what we wanna do is we want to dip this in here. Get it nice and soaked. Okay, very sudsy. I will blow into it, let's see what we get. And if I start blowing, a bubble snake. Pretty cool. And then you can just kind of hold on to it and observe it and admire it. And of course, notice the surface tension. All the bubbles are clinging to each other. They don't feel like flying off and floating around the air. They're all clinging to each other because the hydrogen molecules are attaching to the oxygen molecules. And this is very cool. Now, when I found this, they had an idea that I can't do for you right now. And with that, the idea is to take food coloring and put food coloring on your washcloth in various places and dip it then and blow, and you'll get colored, a colored snake. I don't have food coloring. And I can't run to the store for food coloring in this day and age. It's not serious enough for me to do that. But if you do have food coloring, I would definitely suggest you do that. In fact, I would like to know how it works, what it did for you. So this is the experiment. What I'm gonna ask you to do is run this experiment just the way it is, and then I'm gonna ask you to come up with what's called a variable. I'm gonna ask you to change one thing about this and run an experiment on it and see what different results you get. For example, let's try different kinds of soaps. Okay, everything else is the same bottle, same washcloth, same everything. Let's just use different soaps. Do we get different effects? Or let's leave the soap alone. Let's use different fabrics. Let's use washcloth. We could use a paper towel. We could use various things. So I want you to come up with 3 different things that you would use for one variable. Okay, the way it's set up, and then change something about it. Instead of using water, you could use other liquids as well. Do one with water, do one with something else, with soda, do one with milk. Does it change anything? So I want you to have a lot of fun with it, and then there'll be a Google form that I would like you to fill out and share with me, and we'll use that as for me to see that there was some learning going on. What I will do is, when I do my next science presentation, I will choose probably the most thoughtful, detailed responses and share them as a shout out. Like, good job guys, you really told me some great things that you learned. Okay, until next time, take care.